Hi, welcome back to lecture 6. This lecture is titled How Fast? And so in this lecture, we're going to imagine that we drop a ball from some high distance, like say a tree in your backyard. And we want to know if it falls some distance delta x, or really displacement delta x, how fast is it going right before it hits the ground? And normally the way we would do this is a two-step way, but what we're going to do is derive an expression which allows us to get that velocity given this displacement delta x. And so how we're going to do that is we're going to use two of the equations from the last lecture. This first equation is just for the velocity as a function of time. I should really write this as a function of time here. V of t is equal to an initial velocity plus g times t, where g is the constant acceleration we experience here on Earth, 10 meters per second per second. And so the first thing I'm going to do is I'm going to rewrite equation 1 as v of t minus v naught equals gt. And v of t minus v naught we're going to call delta v. Okay, that's just our change in velocity. And then I'm going to solve. Then I'm going to solve for time to see how long it takes to fall. And so doing that, just a little bit of algebra, we get that this time is equal to delta v divided by g. Okay, now we're going to substitute this time value into equation 2. And so substituting 1 into 2, we find that x of t is equal to x naught plus v naught times t, but t is delta v over g, plus 1/2 gt squared. But again, t squared will be delta v squared over g squared, delta v squared over g squared. All right, now we're going to simplify a little bit. I'm going to take x of t and subtract from both sides of this equation x naught, so I get a delta x, because remember that delta x is equal to x of t minus x naught, which is going to be just equal to v naught times delta v, but now I'm going to substitute in for delta v, v of t minus v naught divided by g plus 1/2. I'm going to simplify the g's here. We've got g times 1 over g squared is going to give us 1 over g. So that's delta v squared, but we're going to write that as v of t minus v naught quantity squared all over g. All right, the next thing I'm going to do is I'm going to multiply both sides by 2g. Doing so will cancel this half here, but it'll put a 2 on this term here. But we'll get rid of the g in the denominator of both of these terms, and so I'll get that 2g times delta x is equal to v naught times v of t, which is v naught times v of t, minus v naught squared. And both of these are times 2, so I'll put a 2 in front of both of them. There we go. Plus, now I've got to square this term out. So it'll be a v of t squared. Then we'll have v of t times v naught, or minus v naught, and then also minus v naught times v of t, so that'll be minus 2 v naught v of t. And finally, minus v naught squared is going to be plus v naught squared. And if we look at this, we see that we've got a 2 v naught v of t and a minus 2 naught v of t right here. Those will cancel out. And we'll be left with 2g delta x is equal to minus, well, let's do it this way. Let's do it v naught squared minus 2 times v naught squared. And I think that is close to what I want. Let me just check something. Do I have a factor of 2 out of place? Yes, I do. Where did I get this factor of 2? Oh, I'm sorry, I haven't finished this yet. Plus v of t squared, and v naught squared minus 2 v naught squared is just minus v naught squared, so I'll get v as a function of t squared minus v naught squared, and this is equal to 2g delta x. And so now I can solve a problem like I was talking about before. I said it was 30 feet, so let's use feet per second for our acceleration. And the gravitational acceleration in that case is 32 feet per second per second. And if we're going to consider 30 feet, we'll let delta x be 30 feet. So we'll have 2 times 32 times 30 feet times 30 equals v squared is what we're solving for. And let's let v naught squared be equal to 0. So it's falling from initially at rest. So it has an initial velocity of 0. So now all I have to do is solve this equation. So I do 2 times 32 is 64, and then times 30 equals v squared. And so then we can do this problem here. 1800 plus 120, so that's 1820. And the units on that are going to be, feet times feet per second squared. So that's feet squared per second squared. So this will be in feet per second. So if I take the square root of both sides, I will get that v is equal to the square root of 1820. 1600 would be 40 meters per second. So if we punch this into the calculator, we can get an exact evaluation of that. Oh, you know what? Not 1820, 1920. I had to add 120 to that, and I forgot. Oh, that was great. 1920. Okay, so little math error there. It happens. So 1920, the square root of that is 43.8. So that's 43.8 feet per second. Now, if we wanted to convert that into miles per hour, we'd have to convert this to feet per hour and then convert the feet into miles, but we're not going to do that. We're just going to stop this here.